Hi, welcome to this talk on how I built a social network in just a few weeks using serverless and GraphQL, which is related to a project that I did for a client recently where I built a backend for a new social network that lets you, mostly university students, register your sporting interest and find other people to do sports with. You can arrange your activities like a basketball match and have a group chat or one-to-one chat. And the client is privately funded, bootstrapped startup, so there's a lot of constraint on budget and therefore development time. But they also needed to have something in place before the new semester started. So from the get-go, I had some pretty clear goals to work with to help me drive technology choices and what approach I should take. We want to maximize the speed of development because the client can't afford a long development cycle. At the same time, they need something that can scale to millions of users if it takes off, as they already have agreements with local universities in Belgium to roll it out to tens of thousands of students right away. The system needs to require minimal upkeep because, again, the client can't afford to hire a full-time team to look after this once it goes live. So the system pretty much have to just run itself and not fall under. And it also needs to be cost efficient as well, even as we scale to hundreds of thousands or maybe even millions of users. So the project was put together with a very small team of just 3 engineers, including myself, where I was working part-time, averaging about 2 to 3 days a week for a good about 4 weeks or so on my part. We didn't just build one mobile app. We also built a CMS system as well for the app, which allows the founders to onboard the new universities and also to allow the university admins to manage their profile as well as the sporting programs. So I'm not going to show you the full architecture, but here are just a few of the key components and how they fit together. So we have CloudFront and the S3 for image assets and such. As for authentication, we use a Cognito. There's one Cognito user pool for the mobile app, and then there's another one for the CMS. For the backend, it's all done in the GraphQL using AWS AppSync. Again, there's one for the mobile app, and then one AppSync API for the CMS. And they each have resolvers that point to various databases in DynamoDB for simple get, put, and query operations. For anything that's more complicated, we will have a Lambda function resolvers for them. And those Lambda functions would be doing more complex things, operations against the DynamoDB tables or other data sources we have. You can use pipeline resolvers instead of Lambda for some of these, and sometimes you do, but in most cases I still kind of just use Lambda resolvers because I find it a bit easier to work with, and it'll be easier for me to hand it off to somebody else later as well. We use Algolia for search, and Algolia is probably the closest thing you will have to a serverless Elasticsearch. And to get data into our Algolia indices, I have DynamoDB streams to trigger Lambda functions to then synchronize any data changes to Algolia. For example, whenever a user creates or updates their profile or they start a new activity in the app. And also captured a bunch of different business intelligence events from the different Lambda functions and use Kinesis Firehose delivery stream to buffer and bash them into S3 so we can then run the BI analytics and reports against them with Athena. Again, this is not the full architecture diagram, but it's a summary of the key services that I used and how they fit together from a high level. I'm not going to show you the full architecture. It's just going to be a lot of lines between AppSync and DynamoDB and Lambda. So moving a level up, we have multiple AWS accounts, which is a good security practice and helps limit the blast radius of any security breach you may have. And it also gives you consolidated billing and the billing report across all the different accounts you have. I use AWS Organization for managing these accounts, and I had the 4 independent organization units for dev, staging, and the production, as well as a separate org unit for accounts that manage shared resources. For example, there's a shared users account for SSO or single sign-on, and a shared account for collecting all the old information, such as CloudTrail logs. At the organization root, I have a couple of service control policies or SCPs to deny access to all services outside of the EU West 1 region, because I know that's the only region we're going to use. And remember, all of this was done by one person working part-time for a couple of weeks, and it's only possible because I could stand on the shoulders of giants. And really, all the hard work is done by AWS and other service teams, and I can rely on the really good tools like the serverless framework to help me manage and deploy my application. So something about myself: I've been working with AWS for over 10 years now, and I've been one of the AWS serverless heroes since about 2018. And I've been really focused on serverless technologies for a number of years now, including working on and migrating another social network a couple of years ago to run pretty much entirely on serverless. And you can read about that particular journey on the link down below here. So nowadays I work as a developer advocate with Lumigo, which is a troubleshooting platform for serverless applications. And I spend about half my time working with Lumigo, and the other half my time I spend working as an independent consultant, where I help other companies adopt serverless technologies successfully and help them with training, advisory, and sometimes like this particular client, I would take on a delivery project for them to actually build the MVP for their product. In my spare time, I've published a few books and video courses, including a new video course called the AppSync Masterclass, where I show you how to use AppSync and GraphQL by building a Twitter clone using Lambda, AppSync, DynamDB, and vue.js, and so on. I've also run a weekly podcast where I talk to other practitioners about how they're using serverless technologies in the real world as well. So, starting with the basics, I'm sure most of you have heard about the GraphQL list, so I'm not going to take too much of your time here. So GraphQL has basically a schema language that lets you define the data types and operations that you support, including queries for fetching data and the mutations for, mutating them. And so when a client were to send a query or mutation operation to a GraphQL server, Apollo is probably the most popular implementation of GraphQL server, and the server would validate the query against the schema, you pass system, and it would then fetch data from the different data sources and stitch the results together in the format that the client has asked for. So think of it as your backend for frontend, except you don't have to write bespoke endpoints every time the client wants another piece of data or he wants them in a slightly different shape. As for AppSync, it's basically a managed GraphQL server and lets you map those queries and mutation operations as well as the data types to different resources in your AWS accounts. And it supports DynamDB, Lambda, Aurora, and Elasticsearch, as well as any HTTP endpoints out of the box. So for example, as a logged in user, I need to fetch my profile, and in this query operation, I'm able to fetch everything I need, including my ID, my first name, last name, gender, what sports I'm interested in. These are all mapped to a profile table in DynamDB, so AppSync will fetch my profile using the authenticated user ID that the Cognito provides as the user is signed in. But wait, the list of sports in my profile, they only contains the ID for the sport, because we want to be able to change the, say, display name or image URL for the sports. So we don't want to bake them into every user's profile. So we're going to need to expand those into full objects and fetch the image URL and display name for each of the sports I'm interested in. So within the GraphQL, that's called a nested resolver. In this case, AppSync can then fetch those information from a different table, a sport table in DynamDB. So we're good there. There's no need for the client to send two separate requests, which save us additional round trips. And as for my activities, since I have many activities, so when I fetch my profile, I just need the first page of it, and which is my next set of activities, which is likely all I care about. So AppSync runs a query against the activities table where the data is stored, with my user ID as the hash key and the timestamp of the activity as the range key. So we can easily get pages of activities in descending order in time. And since other people might ask to join my basketball match next week, I also want to fetch any requests I have as well, so I know which ones I want to accept, which ones I want to reject. Again, we only store the user ID in those requests, so to display those requests in the UI, we're also going to need to expand this into those users' public profile, so we can get their names and the profile image, etc., etc. And so we have another nested resolver that would have to make the get request to the profiles table to fetch the information about those users who has asked to join my basketball match. So as you can see, it's all very, very flexible. The client can basically ask for any information they need, but you can probably also sense a danger here as well, that the client might end up just asking for way more information than he needs, and you can have a very deeply nested queries that can start to impact your performance and the cost. So luckily, you can mitigate some of this by enabling caching in the AppSync, which lets you enable caching on specific resolvers, and you can adjust the cache TTL or time to live for each resolver as well. And to prevent any further nesting, and to also to prevent the leaking any personal information like date of birth, I've got a separate data types for your profile, which only you can fetch, and your public profile, which other people will see whenever they find you on the app. And it's also a much flatter structure, as in the public profile is much flatter structure that doesn't allow for much more nesting afterwards. And so that one query returns all the information I need to render this profile page. And when you see other people's profile, you're looking at the data that's available through the public profile only. So you won't see other information around the date of birth and their location and so on. So AppSync itself is very, very scalable. They also have this GraphQL subscription implementation that can support millions of connected clients. And your AppSync API is deployed to multiple availability zones out of the box, which also gives you a really good baseline for resilience as well. And you only pay for what you use at the $4 per million GraphQL operations. And as I mentioned earlier, it has got support for caching, which charges you extra. Essentially, you're going to be paying for uptime for some memcached node, but you don't have to manage the memcached node yourself. It also has got built-in the monitoring with CloudWatch and the CloudWatch logs, where you can see high-level metrics like the number of API requests, error count, and latency, which is great, but unfortunately, these are all aggregated at the API level, so it's difficult to tell which resolver is causing problems when a single query can potentially involve many, many resolvers. Luckily, you can also enable logging, and which can give you a lot more information about what's actually going on, so you can at least narrow it down to specific requests that took a long time, and then inspect the resolver logs for what that request has done to figure out which resolver is actually the problem. And for performance issues like that, you can also enable X-ray, which really shines a light on what's going on under the hood and shows you where the time is taken. And you can see this that this particular GraphQL query operation has resulted in quite a few different DynamoDB table calls behind the scenes. X-ray also shows you a service map, so you can get a high-level view of which services your AppSync API is talking to and the overall health and the performance. And it gives me all of this, and I don't have to manage any servers, which is amazing. But you may have also noticed that I have quite a few different DynamoDB tables here. I think that the last count I had about 18 tables in total. And if you've been following what's happening in the DynamoDB space, you might have heard about the single table designs and wondering why I didn't use them, and I didn't just put all of my tables into a single table. I mean, I do use the same modeling techniques that people use with single table designs, and I do occasionally put different entities into one table, but I limit that to things that tend to be queried together. Other than that, I don't see why I should force myself to just put everything to one table, because most of the time it's just impractical. And I'm also quite careful when it comes to using global segmented indexes, because there are some serious impediments that you can run into when you have too many of them. For example, CloudFormation can only update one global secondary index at a time. So if you ever need to add two global secondary indexes in one update, then you're kind of stuck. If you ever need to rename a global secondary index, tough luck as well, because there's only one update you can do. And to rename a global secondary index, that requires a delete and then update and then insert a new index. So you have to be really careful and in terms of how you manage your commits and what you push through your CI pipelines, so that you only update one global secondary index on a table at a time, which is just so easy to mess it up. And then when you're building something new, you also haven't quite figured out all your access patterns yet. And whenever you change your mind, those changes are going to be really difficult when you're using single table, especially when you can't deploy multiple global secondary index updates in one commit. So do you want to deal with that? I know I didn't. Often when I need to read a couple of related items from different tables in one request, which is one of the reasons that people might tell you why you should consider using single table designs. Well, the thing is, AppSync actually takes care of that complexity for me already, and is able to make requests to different tables in parallel, and then stitch them together for me very nicely. And if I was to use single table designs with AppSync, then I would also have to write a lot more custom VTO code than I would have to otherwise. And I don't know anyone who actually likes VTO. It's not exactly the nicest thing to work with. But what about the potential cost savings? One of the arguments for single table design is that you can use one query to fetch multiple items, and the way the read units are calculated based on item size means that you can potentially save a lot of read units with queries. So you have one query to read 4 items as opposed to which actually counts as one read unit, versus if you make 4 separate get item requests to 4 different tables, which will count as 4 read units. But you know what? I find that a sensible caching strategy is going to save you far more than single table design is ever going to save you, because you cut out most of the requests to DynamoDB before they even happen. And in this particular application, I managed to get the steady 99% cache hit rates on average throughout the entire day. And after we've been live for about a month or two, and we average around 200 to 250,000 API requests per day. And a lot of those requests are pretty much multiple DynamoDB calls, so they are quite intense and fetch a lot of data from DynamoDB. But if you look at our bill for the first 2 months, our DynamoDB cost was really, really low. Even a high scale, like if you're talking about Amazon.com, then sure, those small cost savings can become quite significant, and that's where using single table designs can make a lot of sense from the cost perspective. But for application like this, I don't need to optimize for the best performance and cost, and the multi-table design is just more than sufficient, at least for the foreseeable future. And the thing with single table design is that it's just much more complex and requires a much more thorough understanding of how DynamoDB works under the hood, especially in terms of global secondary indices. So I don't remember who actually said this, but I also really agree with this, that you want to design your systems as if it's run by idiots, because one day it will be. And most of the time, the idiot is yourself in 3 months' time, when you don't remember what exactly that you did, why did you make certain decisions 3 months ago. So as much as I enjoy and I do use the single table design techniques, and I do use them sparingly, I just don't think it makes practical sense for me to arbitrarily restrict myself to using one table for everything. Okay, so in terms of authentication, as I mentioned before, we use cognitive user pools, and I set up identity federation so the users can sign in using Facebook and Apple as well. And on the client side, we use the amplify.js library to integrate with Cognito, which makes things a lot simpler as far as authentication is concerned. However, I didn't use the Amplify CLI to create and configure the cognitive user pools. I configured them with CloudFormation in the serverless framework. because, well, I already know how to do it and I've done it many times. And if anything, I kind of want to know what's been configured. And when I think about Amplify CLI, I think it's great for quickly bootstrapping a new app, especially for a team that doesn't have strong experience with AWS and Cognito. It helps you get something going really quickly and give you some sensible defaults. But also heard that it doesn't cope so well with changes, and a few people have told me that they've had to delete their entire stack when you got stuck and they can't deploy certain changes. Again, not something that I was willing to deal with on a client project. Amplify could also provision and configure DynamoDB tables and the AppSync APIs for you as well, but I don't agree with some of the default decisions that it makes. For example, how it defaults to using DynamoDB scan for list operations. And in this particular case, the DynamoDB schema and access patterns are really quite important, with potentially huge scalability and cost implications. So I want tighter controls around that, and I need to understand my access patterns intimately as well. And ultimately, I think Amplify CLI just hides a bit too much details from you, and not being able to drop down to CloudFormation level easily when I need to make some changes and customize some settings is going to be restrictive, and later on as the project gets more complex. So moving a bit closer to the code, instead of the Amplify CLI, I use the Serverless framework to help me package and deploy the application. Because it's mature, it's got a great community around it, and it's also very extensible as well. There's a whole load of plugins from the community, and we're going to see 2 of them in a minute. And I was also very familiar with it. It's been my go-to solution for a number of years, so I'm very proficient with the serverless framework. In this case, I've got one repo for the whole backend, and everything is configured in one serverless YAML, and it's deployed as one CloudFormation stack. So resource reference and all that is very straightforward. Even as the project grew and to deploy, I just have to run one command, serverless deploy, and that's it. And to make it easier for me to configure all these different resources and resolvers I had with AppSync, I used the Serverless AppSync plugin, which makes things a lot easier. As I mentioned, I had the 2 AppSync APIs, one for the mobile app and one for the CMS. So I broke those into their own YAML files, so that things are a bit tidier, a bit more manageable without having like one gigantic serverless or YAML file. And each of these files, they will look something like this, where I configure the right Cognito user pool. I configure logging. For example, in production, we don't want to log everything because it will generate too much logs to CloudWatch logs, and that has a cost associated with that. And then I would configure my resolvers and data sources in the same file. For many of these resolvers, we'll be going straight to DynamoDB as much as possible. So the request and response template have to be written in Apache VTO, which is the same templating language that the API Gateway uses as well. So I've been quite familiar with it as well. And honestly, I think in most cases, the feature documentation give you some nice examples that you can just copy for those those direct DynamoDB templates, resolvers. So you can just change the fields to match the way you need to do. In most cases, you don't have to write custom VTL code per se. And as the project grew, I also quickly hit the 200 resources limit, which luckily AWS has since then increased to 500 resources. But at the time, it was still 200, and we hit that limit pretty quickly. So that's where the split stacks plugin come in, which allows you to split your one stack into multiple stacks by splitting some resources into nested stacks and then reference them from the main CloudFormation stack. Which at the time of preparing for this, we had well over 200 resources across 2 AppSync APIs, one for the mobile app and the one for the CMS. With I think it's over 200 resolvers, with over 600 CloudFormation resources in total. Which also brings me to then CI/CD, and since the code base was already in the GitLab, I just decided to use the GitLab CI/CD because it's just easier. And one technique I've used in most of my projects is to install the serverless framework as a dev dependency, which means that I don't have to have any extra steps to set up my CI server. It's just npm CI to restore the dependencies, and I've got a helper script that lets me just deploy using the server framework with that one command. So my CI script is literally just two things: npm CI and then the npm run serverless deploy, plus any additional steps for running tests and so on. Since I was talking about testing, one of the challenges with using something like AppSync is that it's a black box. So how do you test it locally, right? So there are tools that let you simulate AppSync locally, but I generally don't bother with them because they don't cover everything, including IAM policies. And honestly, I think those VTL templates are pretty straightforward. If I do need to test them, because I'm writing some custom VTL code, I can also write unit tests that cover those VTL templates as well. But where things really tend to go wrong is in my Lambda functions, where I tend to do more complex things. And for those, I like to test my integration with other services like Algolia or DynamoDB by executing the function locally, but talking to the real DynamoDB tables or the real Algolia index. I don't tend to use mocks or stubs for those, or to simulate them locally with things like local stack, which I just tend to find takes too long to set up and get them to work properly. They're also quite brittle as well, also breaks really easily. And then a lot of times, most of the time, it's just easier to provision the resources in AWS and then use them in the integration tests. And then I also have an end-to-end test that run user stories, like the user signs in, creates a profile, search for activities, join a user's activities, and so on. And I run this against the deployed GraphQL endpoints. So this will always be run after the deployment itself. And if you have any failed end-to-end tests, then great. Use this as a valuable rehearsal for how to debug problems in production. If this step is difficult, then guess what's going to happen when you do have a problem once the system is live? Use this as a signal that you need to improve your logging, how you're monitoring the system, and maybe enable X-ray tracing if you need to. If you struggle to debug failed problems in a controlled environment like your end-to-end tests, then you're going to have a much bigger problem when this thing is running in the wild. So don't optimize for your comfort with local simulators. It's going to give you a full sense of security. And finally, let's talk about AWS organizations and how I got it set up. So I mentioned that I had the several org units and AWS accounts, and I don't want to manage this by hand. So I want to have infrastructure as code for all of this as well. Luckily, there's a tool called the org formation, which gives me exactly that. And it lets me provision and manage my entire AWS organization with infrastructure as code using a YAML, using a CloudFormation-like syntax. And it makes it really easy to template my landing zone, or basically what infrastructure should be provisioned on a new account. Things like KMS encryption keys, VPCs, and so on. So in this case, I was able to declare a master AWS account and a root for my organization, again, all done in code, using a syntax that's very similar to CloudFormation. And I'm able to provision a new account and set up a bunch of alarms with just a few lines of code. And I can attach these new accounts to org units, which I can, again, create in code. I can set up service control policies, in this particular case, to disable access to services outside of EU West 1. I can configure my password policy for my AWS users. And whenever I need to make a change to my entire organization or my landing zone, I just have to run one command to update my entire AWS organization. And then to configure my landing zone, I can configure what is called a task, where I can specify a CloudFormation template and provide the bindings to my organization, which basically says which resources from the template should be created in which AWS accounts by binding these resources to either org units or to specific accounts. And here's an example of one of these templates where I have just a normal CloudFormation template, a resource for an IAM user, but I can bind this resource to a subset of the accounts in the organization using this concept of organization binding, which is a way for you to kind of filter accounts by org units and or account name or by tags and so on. And then here I've got some code to iterate through the AWS accounts that are provided by the binding. So don't worry about the mechanics of how this works, because if it looks a bit strange and alien to you, once you spend a bit of time with org formation, it will start to make a lot more sense. Anyway, to update my landing zone, again, I just have to run one command to update and perform any already updated task I have configured in my org formation template. It's a really powerful tool, and I do recommend that you go and check it out. It's available from GitHub and it's maintained by MoneyU, which is a bank here in the Netherlands. And that's kind of the three main tools I've used in this project: the server framework for deployment automation, AppSync for the managed GraphQL server, org formation for automation around the AWS organization. And if you go back to the goals that I had started with, in terms of speed, well, we got everything done with just a few weeks, which is pretty good going, considering the amount of work that was involved, and I was working part-time as well on all of this. So speed of development, check. AppSync can scale to support millions of users, absolutely no problem there, so check. I had the 0 EC2 instances to manage, no server to manage, no networking, no VPC, and all that. So minimal upkeep, check. As for being cost efficient, we've been live for quite a while now, but then because of the pandemic and the lockdown, the usage level has dropped significantly since the lockdown started. But when we first went live, we were averaging around 200 to 250,000 API requests per day, and our AWS bill for those months was about $60 per month. And most of that was just on the AppSync caching. And considering that we were using about 5% of the cache capacity, that $31.68 is going to stay pretty flat even as we grow our traffic by 10x. And it's going to save us tons of money on Lambda and DynamoDB costs. Besides what you see here, there's another like $15 or so for CloudWatch logs and X-Ray. So all in all, pretty reasonable price to pay for something like this. Oh, and the latency in general is pretty good as well. P99 is stable around 500 milliseconds during the day when people are using it. At night, in the middle of the night in Belgium where the app is live, you can see those P99 going up because there are more Lambda cold starts and other things like that. But overall, we are still very happy with what we're seeing in terms of performance. And that kind of brings me to the end of this talk. I want to thank you guys very much for being with us today. And as I mentioned earlier, I spend most of my time as an independent consultant. So if you want to see how serverless can help you go faster or need some help upskilling your team, then let me know. Go to theburningmonk.com to see how we can work together. And also, don't forget, check out my new course on AppSync. Go to appsyncmasterclass.com and see what we can offer there. And once again, thank you very much and stay safe.